So this is Edexcel IAL Pure Maths 2 8.6 integration trapezium rule. Okay. Do you know what is a trapezium rule or when do you use a trapezium rule?
You would use the trapezium rule when you want to find a certain part of the graph, which they will be given as R, the shaded region.
Understand one thing. Suppose this is your x-axis and this is your y-axis and your graph looks something like this, or I would say your graph looks something like this. Okay. This is your y is equal to f of x. Your graph looks something like this. Are you with me?
Yeah,
Okay. And you have these bounds, that is your B and your A.
yeah.
Okay. So when your graph is something where it is not possible to integrate it or it is difficult to integrate for us, so in that case, we divide our graph into small portions, which is called small trapeziums. So I am dividing it into small trapeziums. If you could see where this is being divided into small strips. This is one strip, this is the second strip, third strip, fourth strip, fifth strip. You can see this?
Yeah,
Okay, fine. So each strip is a trapezium. Each strip is a trapezium. So when I have something wherein it is not possible for me to integrate the function very easily, in that case, to integrate that function, I use the trapezium rule where I divide the portions under the graph into small strips. Understand, more the number of strips, more accurate will be the result. Now, one thing you should know in the trapezium rule is that when you're going to use the trapezium rule, you are going to get what? Area under the graph. When you integrate, what do you get?
we when we integrate, we'll get the area under the graph
Very
bounded by the x-axis.
bounded by the upper bound and lower bound above the x-axis.
Yeah,
When you're using the trapezium rule, what are you going to get?
I'm gonna get the area below the graph, the whole thing.
Area under the graph, upper bound, lower bound, above the x-axis. Correct?
Yeah,
But when you're integrating it, you're going to get the area under the graph will be, which will be an exact value, which will be exact figure. But when you're using the trapezium rule, you're going to get the area under the curve, but the area will be an approximate figure. So I would say it looks something like this. So when I'm
yeah,
using the trapezium rule, you are actually integrating y with respect to x, area under the curve bounded by b and a. Okay, this you do in integration, but when you're doing the trapezium rule, you're going to get an approximate value of this, which is h by 2. There is a formula. Okay, and this is an approximate value. I hope you're with me.
yeah.
Now let's understand this formula. How do you get this formula? I have this curve with me. Do I?
Okay.
Okay. I have this curve with me, and in this curve, I have divided into how many strips? Can you see that?
Yeah, four strips.
It's one, two, and three strips.
Yeah, yeah.
Okay. Each strip is a trapezium. Yes.
Okay.
This is the height. Yeah.
That's the height. Yeah.
Okay. This will be the height, and this would be my A and B. So I could say when I'm using the trapezium rule, I add, for this particular example, I am dividing my area under the graph between B and A into three strips.
Yeah.
Okay, my first strip is this one, my second strip is this, and this is my third strip.
Yeah,
I have broken it down. If you see, this is the H, and H, the height of each one.
yeah.
What do you notice about the height for each of these strips? The height is almost the same.
Okay. Is
Yes,
that like the case for each and every example or no?
yes, for each and every example. If you are using the trapezium rule, using the formula, your heights should be the same. The height of each strip should be the same. Are you
Okay.
okay? This is my A and this would be my B. But I am giving the A and B to my bounds. So I change this into Y0, Y1, Y2, and Y3. Are you with me?
Yeah.
So my first strip area would be half into height Y0 plus Y1.
Half height into
The
y0 plus y1, right?
area of trapezium, yeah.
Yeah. That's just the basic formula of trapezium,
That's
right?
just the basic formula. The second one would be,
Half height into y1 plus y2.
okay, and the third one would be,
Half height into y2 plus y3.
so if I want to find the total area under the curve,
I would add all three of the sums.
so if you're adding all three of the sums, I want you to add it along with me. What will you get? It would be half height y0 plus
y0 plus
y1
y1.
plus half height y1 plus y2 plus half height y2 plus y3. Is this what I'm going to get?
Yeah, that's what you're
What
going to
is
get.
common?
Height. 1
Half
by 2
height.
height. Yeah.
Okay. Then in the bracket, I have y0 plus y1 plus y1 plus y2 plus y2 plus y3.
Yeah.
Okay, so this is going to be half height. If you see, this is your y0.
Yeah.
You have 2 times y1 plus y2.
y1 plus y2. Yeah.
Hmm?
Yeah. And plus y3 because we only have
Plus
one
y3.
y3.
That means the area of the trapezium, the area under the curve, would be, I'm integrating between B and A, y with respect to x. When I'm using the trapezium rule, it is going to give me an approximate value. So I say it is approximately equal to h by 2.
Okay.
Your first y and your last y is single.
Yeah.
If it was your y0, it would be y0 over here, right?
Yeah.
Y3 is your last y, so it's yn. And
So we're
all
gonna put
the middle
y3 in that
ones
position.
and all the middle ones would be 2 times of it. So over here it is 2 times y1 plus y2.
Yeah.
Okay, let's try it with one example. Okay, I have two trapeziums over here. I have figure 1 and figure 2. Take a minute's
Yeah.
time. Try to write down the total area of the trapezium using your trapezium rule. I'll pause the video. Mentally, how to write it. Okay. So when I am saying it is the area under the curve and it is split into how many strips for the first one? It is split into three strips, right? So if I am writing
Yeah.
the formula for it, I will directly write I'm integrating y with respect to x between b and a The total area under the curve will be approximately equal to h by 2. This is your y0. Y0 plus 2 times y1 plus y2 plus y3. This is the way you do it. Okay.
Okay.
Again, I'm saying I'm integrating y with respect to x between b and a. You use these words while solving, so that you have an idea about the words that is being used in the question. It is approximately equal to, I'm saying approximately again and again. What is it approximately equal to? Can you say?
Approximately equal to h divided by 2 into y0 plus 2 times y plus 1 plus y
Y1
plus
plus
2 plus
Y2
2 plus
plus
y3 plus
Y3
y4.
plus Y4
Close brackets plus y5.
plus Y5, and then you close the brackets.
Yeah.
Okay, so this is approximately equal to this. So you use the area of the trapezium when you're using the trapezium rule, you are finding the area under the curve whose integration is not very easy. Are you with me?
Yeah.
Okay. Your general trapezium rule would look like this. You're integrating what you're integrating b with respect to a,
A and B.
y dx. It is approximately equal to your first value would be y0, your last value would be yn, okay, and it is 2 times y1 plus y2 plus this is dot, and it would be yn minus 1. Your height should always be the same, and you get your height by doing b minus a divided by n. Now, what does this n denote? The n denotes the number of strips. Are you with me?
Yeah.
Okay, fine. Now, this is your first example when you have to find the area of the trapezium using the trapezium rule. Can you see? Find the area using the trapezium rule. You have how many strips?
4 strips.
4 strips. It is between the lines where x is equal to 0 and 2. Can you tell me what does this mean?
That is our bound. So B is 2 and A is 0.
B is 2 and A is 0. Okay.
Yeah.
So how would you find the h for me?
H I would find by 0, 2 minus 0
So this is
divided by 4.
it is going to start with what? It is going to start with 0. It's going to end at 2, and your
Yeah.
number of strips is 4.
Yeah.
Correct? You're going to find your h by using the formula b minus a divided by n.
Yeah.
Are you with me? So b
Yeah.
is 2 minus 0 divided by 4 strips. You're going to get your h as 0.5.
Yeah. 2 minus 0 divided by 4. So, yeah, 1 by 2.
Now, with the help of this, can you fill this table for me? I'll wait for you. Okay. So your lower bound was 0, your upper bound was 2. You managed to find your height using b minus a divided by n. So your height was 0.5. You kept on increasing x with 0.5. Are you with me?
Yeah.
Then what did you do to find your y?
So basically, they've given us y equals to root 2x plus 3.
Hmm.
So I inputted the values of x into the equation of y, and you just get the values.
So you get the value of x, the value of y. I'm sorry. Now, can you use the trapezium rule? To find the area under the curve root 2x plus 3.
Yeah.
How would you do it? What would you write first?
First, I would write down
That I am
my,
integrating. This is
yeah.
very important. I'm integrating y with respect to x between b and a.
Okay.
Because I'm using trapezium rule, the answer that I'm going to get would be an approximation.
Yeah.
Half height. Okay. Y0. This would be your last value y, and you're going to write this formula first. Okay. And 2 times this plus this plus this. If you don't remember this formula, you can directly substitute the value. Showing this is a must.
Yeah. Okay.
Okay? And the answer would be 4.437. Now understand one thing what you have to show. When you're using the formula, you will say you're integrating y with respect to x between b and a using the trapezium rule. You're going to get an approximation, and this is the formula. Then in the next line, instead of y, you're going to replace it with 2x plus 3.
Yeah.
Yeah, so it's going to give you an approximate value of this. And then you put it on your calculator and you'll get it. Okay, so this is the trapezium rule. Do it, I'll wait for you.